Hello everyone. I don't know if you guys can hear me, so doing a few tests just for now. And yep. Oh. Okay. Someone told me they can't hear, but I think okay, yeah. All right. Should work. All right. Sorry if you can hear the typing because there's no press to mute. Yep. Okay. So there's no music then. That's great. It's great. It's fine. We can go without. I definitely did not just press play. We're going to ignore that I did that. All right. So for those of you who are joining, thank you so much for joining. First of all, second, click that link inside the chat that's pinned. That way you can get into the Kahoot challenge. For those of you who are watching this later, we have the Kahoot sheet so you guys can upload it yourselves. And yeah, we can go from there. All right. Okay, so we should start in a few moments. I'm sorry if there's an echo. Let me try something. Okay, how is that? Is there an echo now? All right. Okay, so all right, so let's go ahead and start. Tell me if there's an echo again. So thank you for that. So we're going to start the Kahoot. I'm sorry if there's no music. There is something wrong with this that I don't know what, but okay. So first question, Alice has 600 megabytes of data, Bob has 2000 megabytes of data. Will it fit all on Alice's 4 gigabyte thumb drive? And I'm not going to put the answer because then you guys will know what it is. So, yep. So 602, yeah, 602,000. So that would be 2,600 megabytes. Okay, so time's up. So the answer is triangle because, yeah, so basically first thing you want to do is add up all the different megabytes that it has. So that's 2,600 megabytes. And once you get that, to convert from megabytes to gigabytes to etc., from kilobytes to megabytes to gigabytes, it's all by 3 decimal points. So if you move the decimal left 3 times, that would be going to the next level, I guess you can say. That's like a quick cheat sheet. So basically, in this case, if you convert 2,600 megabytes to gigabytes, that would be 2.6 gigabytes, which will fit on the 4 gigabyte drive. Okay. I'm really sorry for... Oh, okay, so there is Kahoot music. Okay, because I can't hear Kahoot music, and I don't know why. But it's fine, it's fine. All right, moving on to the next question. Question 2, select the proper answer. And I hope the pictures show, because if they don't, okay, it does. All right, Alice has 100 small images, each of which is about 500 kilobytes. How much space do they take up overall in megabytes? So remember what I said before. So the hierarchy is kilobytes, megabytes, and gigabytes. So. Time is up. So the answer is 50 megabytes. And sorry if I'm not checking chat because I have it on a different pin, so that's fine. I'm not gonna worry about it. So if you guys have questions, I'll just answer a little bit later, but it's fine. So yeah, so first thing, so there's 100 small images. Each of them are 500 kilobytes. So we multiply those two together. So that would be 500 times 100. so that'd be 50,000 kilobytes. So again, move the decimal 3 to the left if you want to convert kilobytes to gigabytes. Wait, kilobytes to megabytes. I'm sorry. I'm clearly in great shape today. We're not going to worry about it. But yeah, so it would be 50 megabytes. So it's based on that concept. So let's move on then. All right, next question. Select the proper answer. All right, how many bytes are required to encode an image that's 25 pixels wide and 50 pixels tall if you encode each pixel with 3 bytes of RGB data? So yeah, you're going to multiply all of them together, and then remember there's metadata. So the metadata itself is kind of like the address, like of an envelope. So what you want to do is, if you multiply 25 times 50 times 3, you would get 3,750, and basically you add 3 pixels due to that address, so the computer knows what it is. Right now, if you guys are taking principles, I know that the first unit, or like the majority, not the majority of the year, but the main part of your year was trying to like do the portfolio or the project. So I don't know how much you guys have covered, but probably, yeah, every classroom does something different. But we don't worry about that. It's fine. It's perfectly fine. So yeah, so for this question, make sure you have the metadata, I think that's what it's called, included within it. So you're going to add 3 extra to that. So moving on to the next one. Look at my amazing score here, right? All right, so next one. What is lossy compression? Okay, so this is just basic definition. So make sure you remember what lossy compression is. So remember there's lossy and lossless, so keep that in mind. Yeah, it's much harder doing a podcast by yourself. I give applause to all the single students who are doing podcasts by themselves. That's fine, it's fine. Okay, so yes, the answer is A, or the triangle. So when an image becomes blurrier, it's due to the loss of information, and that's lossy compression. So lossy compression will make the image blurrier due to having loss of data. So it's basically like averaging pixels. And for the next one, I'm just going to go ahead because it's tied in, and I'll explain all along the way. So what is lossless compression? So lossless compression is kind of, I wouldn't say the opposite, but very near the opposite. So yeah. And also, if you guys heard the ripping of paper before, I'm really sorry about that. Yep. All right. So time's up. And the answer is B. So when an image retains the same resolution because no data was lost. So for lossless, as in the name, it's lossless. So it doesn't lose data. So therefore, it would but it would remain with the same amount of data that it had before. Oh, the cropping is weird. Let me. That's weird. Okay, because I don't see that. But let me try to fix that. Question mark. I don't know if this is gonna fix it, but okay. I tried to fix it, but it's being itself. Okay, I don't know if that helps, but y'all tell me later if it helps. Oh yeah, it's being really weird. That's great. That's just great. Well then. We love technical difficulties, don't we? Okay, give me 1 second and let me see if it's probably a problem on my end, but yeah, I'm trying to move it over and it's just not, okay, let me try that. Okay, it's being weird. Okay, that's fine, yeah, I'm trying to make it smaller. Okay, I see. Sorry for the technical difficulties. This will be fixed real soon. I'm pretty sure your screen is also moving, so apologies for that. Oh, well, guess not. It's fine. Alright, I guess that would have to work. I hope that works for you guys, but thank you for pointing that out. But okay, so moving on. Sorry for the delay. We can reset this. Which of the following is not a role when creating or naming a function? So remember what functions are and naming them. This wouldn't be an exact question, I believe, but it's something to make sure you know. Might be a question. I don't know. I haven't taken the test yet, so. But the answer is, since time has run out, the answer is C. Did I say C? B. Name has to be an underscore. So that is not one of the rules. For functions, you can have any names that you want to give it. The name should be descriptive, otherwise you wouldn't know what's going on. If you give it a random name, you should probably define what the function does in the comments. That way other people would have an easier time replicating it or trying to copy it and that sort. But name starts with a lowercase. Yeah, so make sure you start your variable names with a lowercase. Also has to do with camel case if you're taking CSA and that sort. So yeah, it's great, it's nice. And my score is forever the highest here. We definitely see it. So what are units of bandwidth? Yeah, this one's another one for memorization. Shouldn't be too hard if you guys remember what the unit of bandwidth is. Okay. Yeah, so time is almost up. So units for bandwidth is bytes per second. Bits per second. No, not bytes, bits. I meant to say bits. Bits per second, and that's basically all I can say for that one. Make sure you guys remember what bandwidth is. But if y'all use y'all watch videos and that sort, you can commonly yell at your Wi-Fi for having low bandwidth. So moving on. So in a for loop, for variable I equals 0, I is less than what number? I plus plus. What does I less than that number represent? Or more specifically, what does the pound sign represent? Or what is it trying to? Yeah, what is it trying to tell us? Yep. So the answer would be D. So the number of times the for loop would repeat. So this is also in coding a lot in CSA, but CSP does less with coding, more with coding abstraction. But yeah. Oh yeah, we do have an abstraction question later on, but that is for later on. Yeah. But yeah. All right. I swear I'm good, guys. Don't worry about me. So moving on from that, question 9. What is displayed when running the code? And hopefully the image shows. Okay, great. So 3 is saved to A plus 5 is saved to A, 3 equals C, or 3 is saved to C, A plus C is saved to A. Display A, display C. So you have to code trace here for a bit. It'll be fun, I promise you. Yeah. So, yep. Yeah, it's really hard to hold a conversation with yourself. But I'm going to try. So, okay, so the correct answer is C, or 11.3. So, how is this possible? So, this isn't possible, and what y'all should do is just give up. Just kidding. Don't give up. That's the last thing you should do. So, what you want to do is basically that kind of covers it, but you basically add the number that's assigned to A, add 5 to that, and so there you have A. So if I'm not wrong, because I don't remember what the first one was, it's covering it, but displaying C, so C would be 3, and then if you add C plus A and save that back into A, that would equal to 11. So if I'm going to reverse this, 11 equals 3 plus something, so that would equal to 11 equals, hold on, I'm trying not to confuse myself here. 11 equals 3 plus 8, so this would be 8. So 8 plus, this would be 8. I'm sorry, this would be 8. 8 equals what plus 5, and that would equal 3. So the original one would be 3. So, yep, I don't know why I did that, but just for you guys to know. And I hope I did not do that wrong. If I did that wrong, Alright, so moving on. And again, having the greatest score on the scoreboard right now, as you can clearly see. Which is the correct answer? There is none. Alright, a computer can use 6 bits, oh, I keep saying it wrong, 6 bits to store non-negative numbers. Which of the following will not give an overflow error? So remember what an overflow error is. So first, make sure the bits, you know what the numbers are, and then from there. So yeah, so the answer is D, 2 and 3. So yeah, so make sure you know your binary conversions. If I'm not wrong, that's what this is asking, but I'm doing it by hand right now. Clearly, you can see how much I prepared for this. Just kidding. 13, 14, 15, 16, 5, 6. Yep. Okay, so it's asking which will not give an overflow error, so that means it has to be below that. And if you calculate out the binaries, so for 6 digits, for binary you count from right to left. So for each incremental byte, you multiply by 2. So starting from the right, the first box would be 1. Go left and then put 2 times 2, so it would be 1, 2, 4, 8, 16, 32. And once you get that, you basically add all of them together to know what number you can put. So for 6 bytes, yeah, not bits, bytes, boots, same thing, boots. For 6 boots, it's 63. So 63, 2 and 3 would be equal to or under 63. So those would work. So yeah, moving on. See how much I'm winning? I am definitely winning this game. All right, next question. Which of the following would be a good variable name to allow the view to refresh the screen? Okay, that's a mouthful. So yeah, so this is just talking about good variable naming. So if you're naming variables random names, that's not very good because you wouldn't remember them, or you'll get lost and referencing them, etc. Just be a hassle. So just name your variables good, people. So yeah, so the answer is C, button refresh, as the other ones don't really make sense. That one is the most reasonable or deductive answer, I guess you can say. So yeah, moving on. Yeah, definitely ignore how I did that. Just we're not going to worry about what I did. Which of the following would be a valid variable name in the App Inventor? So this one's a more specific question, but it's fine. Just remember your variable name rules, and you should get this right. Alright, so time is up, and so the answer is B, or last name. So the reason why is because first, you need to start with the lowercase. If you just look at the uppercase ones, you can cross those out. And then the other one is it shouldn't have like the quotation marks. So last name would be the good variable name. Or valid variable name, I should say. So the next one. So which of the following symbols can be used as a variable? So remember your variables, not variables. That doesn't make sense. Remember what can be used for a variable, because not everything can be used for a variable. If y'all want more paper ASMR, just tell me. I can clearly give you guys paper ASMR. Okay, so the answer is X. So X can be a variable. False can be a variable because that's already for Boolean operations. And 10 can be a variable. That's integer. And hello with quotation marks cannot be a variable either because it is a string. So, yep, there's that. Moving on. We're almost finished, guys. We're almost finished. So, true or false? Different kinds of algorithms can be developed to solve the same problem. So, think about this really hard. It's a very, very difficult question. Yeah, just think about this problem. So the answer is true. Different algorithms can be developed. So it's definitely not just one type of algorithm. Definitely there are multiple that you can use to be able to solve a problem. So for example, you can, well, me trying to make an example isn't the best, but I'll use a very, very, very abstraction. Yeah, definitely using the same word twice is great for definitions. So let's say I am lazy to get up from bed in the morning, right? And so the first option were to be to get an alarm, because apparently I don't have an alarm clock, but we don't worry about that. Second is make sure you don't run out of battery so your phone doesn't die. But no, just kidding. So the first one is get an alarm clock, right? The second one is get someone to throw you out of the window. That can also wake you up. So there's different ways. My point being is there's different ways in which you can solve a problem. Same thing for algorithms and programming. All right, so moving on to the next question. We're almost finished, guys. So convert A7 hex to binary. And I know hex is supposed to be subscript, but Kahoot does not allow that. So we're just going to ignore that. So A7 subscript hex to binary. Okay, remember your hex conversions and your binary conversions. So let me just write that up on my paper real quick. Okay, time is up. So yeah, so I'm doing this with you guys, but A7 hex. So if you remember your hexadecimal conversions, hexadecimal goes from 1 to 9 and then from A to F. So basically A would be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it would be A, B, C, D, E, F. So A would be equivalent to 10, and then 7 already gives you. So then you need to convert it to binary. So make a binary chart. So again, draw, I don't think we need that many boxes, but you can draw 8 boxes if you want. But so start from the right, put a 1, and then multiply by 2. So that's 2, and then 4, and then 8, 16, 32, 64. I don't think we need to go over that. Anyways, so for 10, basically we only need to go to 16. So we just need like 5 boxes. But so whenever you have like a conversion problem, get the number you know and add a box above it. So right now we know it's 10. So the next box would be 16. So just add a box above it. But to get 10, counting from 8, so it would be 1, 2, 4, 8. 10 would be 1, 0, 1, 0. So if you guys don't remember what binary is, that would be a problem, but that's fine. That's why we're here. So binary code is written in 1s and 0s. So think of it as a light switch. So you have 4 light switches in a row, controlling 4 different light bulbs, right? So if you turn that light bulb on, it represents something. In the case of the light bulb, it represents the light being turned on. But in binary, it represents that value getting turned on. So 8 getting turned on, that means you include the 8. 0 means it's off, you don't include it. So 4 would be 0, 2 would be 1, so you turn it on, and then 1 would be 0, so you turn it off. So that would be 1 0 1 0, and we do the same thing for 7 basically, but we're going to start with the 8 again. So 0 and then 7, so that's 4 plus 2 6 plus 1 7, so 0 1 1 1. So conversion of A7 hex would be 1 0 1 0 0 1 1 1, which is what we see with A over here. I hope that was relatively clear because it took me a while to understand it as well, so don't worry. All right, so moving on, and I hope when I end this stream it doesn't cut off, but it's fine. I'll just stream for a minute or two after and talk about my life and childhood stories, which I'm sure you guys love if you haven't heard Shadow stories before. Shadow's childhood stories. Anyways, so true or false? So high-level programming are built on top of low-level languages to provide more abstraction and functionality that combines low-level operations into commonly used procedures. Ah, my throat is dry. Let me drink some water. A lot of ASMR here. All right, so so true or false? I'm not gonna reread it, but the answer is true. So the reason is, if you don't remember what high-level or low-level programming language is, think of it as low-level is machine code, or what, like basically binary, and high-level is like Python, JavaScript, whatever, etc. There's a ton. But my point being is, the reason why abstractions exist is to make the programmer's life easier. So if we had to program in machine code, that would take forever, and debugging it would be more of a pain than it is now. Much more of a pain. But think of it like driving a car, right? Or think about like your heart beating. If you have to control every single aspect of your body, I don't think we would be able to survive for very long, because you have to say like, blink, beat your heart, breathe, you know? But same thing for a car. You don't need to know how cars work, how cars work. So you don't need to know the pistons. You don't need to know how the engine works, etc. So it's the same principle here. So high-level programming languages makes it easier for programmers to code. So moving on, yeah, I'm definitely gonna win this. Like, you can clearly see I'm gonna win this game. So 17. Convert 100101 from binary to a base 10. So base 10 is basically just numbers. So don't think about that. Let's write our binary chart again. So from right to left, just write the numbers 1, 2, 4, 8, 16, 32, 64, and then 128. Right? So 100101. So put that underneath what you just wrote, going from left to right. So 100101. Hold on, did I say that wrong? 100101. Okay, so 100101. You don't need 128 then. That's fine. It's fine. Okay, so 64, 32 0, 16 0, and then 8, and then 4020, and then plus 1. So if you add that together, 6, 7, 8, that's 72 plus 1 equals 73. Whoa. So yeah, so let me correct that. You don't need to have 8, you just need to have 7 in this case. But yeah, so just make sure you know where to place the numbers, otherwise you'll get the wrong answer. That is not good. And we are almost finished, folks. We have 2 questions left. So first one, what is the minimum amount of bytes required to store the number of 240? And that is base 10, by the way. I didn't write that, but that's what it's supposed to be. So 240 shouldn't be that difficult, right? So remember what I was saying before, how you need to write a number above that, just to make sure. You don't have to. I want to pick up again. But, so let's write 128. Oh, okay, let's go from right to left. I'm going to go from the beginning again. Excuse me. Okay, just hiccuped. But going from right to left. So 1, 2, 4, 8, 16, 32, 64, 128. What's 128 times 2? I can't mental math. We don't worry about that. 256, right? Okay, 240. So we don't need 256. We're going to start at 128. So 128, definitely a 1, right? Okay, so let's add 64. So that's definitely can mental math. 192. So yeah, it's still lower than that. So let's put one. Oh yeah, let's put a 1. And okay, so technically we don't have to solve for the binary, but I'm just going to solve it anyways, just for fun, and just for you guys to get more practice. But okay, so let's add 32 to that. Let's see what number that gives us. 32 to 192. We get 224, which I mean, we still need, right? So then we add 16, so 224 plus 16. And I hope my math isn't wrong, because if it is, I will just cry. So 16, we need that 1. So 8, we don't. 4, we don't. 2, we don't. 1, we don't. So if you add that, that's 1, 1, 1, 1, 0, 0, 0, 0. And yes, you do need to put the zeros. So yeah, so basically, yeah, okay, so let me add why you need to put the zeros, because if you didn't put the zeros, it would be like someone stealing your light bulb. So there's no more light bulb there, right? It's like people stealing my brain cells. Okay, so, all right, so a cheat code kind of way to know how many bytes you need is to go a number above. So you remember how I went to 256. So going a number above, you know that that number definitely isn't right. And since you know that light bulbs can be stolen, or in converted to this problem, you need to write the 0 in the bytes. There will definitely be however many that's after that. So starting from 128 and going to 1, all the way there's 8 if you count in total. So yeah. All right. We're on the last problemo. Wow, these people are doing great. Definitely not bots or anything, right? Okay, so what's the correct answer? Okay, it's this time again. Alright, so saving 8 to A, saving 5 to B. Okay, that's great. So C is B minus 3. So 5 minus 3 is 2. So why am I solving it out loud? We're not going to worry about it. So 2 is saved to C. 2 minus 2 is 0. 0 is saved to B. I kind of gave you the answer, but I didn't, so that's fine. So display A. So what is A? A is 8, right? Okay, so D, we got 0. Whoa. Okay, so display 5 divided by 0. If you remember your math, and if you don't, I'm sorry, but this is CSP, not math class, so go watch the Calc podcast. So 5 divided by 0 is actually not possible, because it's a divide by 0 error. So if you're not too clear on that, yeah, just remember that you can't divide something by 0 and still have it not being undivided. But yep, and I think that is it, everyone. Whoa, I'm above. I am way above the podium. I'm just, just soaring above. I'm so amazingly great at this that I'm above the podium. Like, I'm not even there. Enough of the jokes. All right, so thank you everybody so much for joining with us today. Make sure you like and subscribe if you're on YouTube. Check out our Spotify and our other stuff on our website, which is in the pins, so just click that. It would be much appreciated. Please subscribe. It tells us that you guys help support us. It's just a click of a button, and you guys don't have any stats for that, so no one's gonna see how many people subscribe to it. So just click it. But thank you everybody so much for coming. Go on our website. We have notes and that are updated every year, which this year we're still writing, but we are having a lot of great stuff there. Flashbacks to A-Push and their huge documents of notes. But we have great resources, so you guys should go check that out. And yes, the reason why I'm saying a very extended outro is because I'm trying to drag on time to make sure the YouTube live stream doesn't die on me. I did promise a shadow story, but I'm not sure which one to tell you guys, so it's fine. We won't have Shadow's life stories. So yeah, so if you guys want the Kahoot to these, go check out our website as well. They are in Google Drive. And yeah, so that's basically all we have for today. Thank you everybody so much for coming. Make sure you check out the other resources, and then also go to our Discord because we have live help there. But all right, I think we can end this because I think YouTube's not being a bad YouTube, and we can proceed with this. All right, thank you everybody. We will see you next time. Bye bye. All right. Oh yeah, I need to end the stream, right? That's unfortunate. I feel so much more respect for single tutors for being able to do a podcast by themselves. But all right, guys, see you later.